Before we further explore database technology, let's step back and see how data management has evolved. This will allow a proper understanding of the legacy problems many companies are still facing. In the early days of computing, every application stored its data into its own dedicated files. This is known as a file-based approach and is illustrated here. Suppose we have a traditional invoicing application, written in programming languages such as COBOL or C, for example, that makes use of customer information such as customer number, customer name, VAT code, etc., stored in a separate file. A separate application, such as a customer relationship management system, makes use of a different file containing the same data, such as customer number, customer name, turnover, etc. Finally, a third application, a geographical information system, stores information such as customer number, customer name, and zip code in yet another file. The data files only contain the data itself. The data definitions and descriptions are included in each application separately. An application can make use of one or more files. As more applications are developed with corresponding data files, this file-based approach to data management will cause serious problems. Since each application uses its own data files, many using similar data, duplicate or redundant information will be stored, resulting in a waste of storage resources. If this is not appropriately managed, there is a danger that customer data is updated in only one file and not elsewhere, yielding inconsistent data. In this file-based approach to data management, there is a strong coupling or dependency between the applications and the data. A structural change in a data file necessitates changes in all applications that use it, which is not desirable from a maintenance perspective. It is hard to manage concurrency control, or the simultaneous access by different users or applications to the same data without conflicts. For example, if one application performs a cash transfer whilst another application calculates the account balance, and the data operations of both applications are interleaved for efficiency, then this can easily lead to inconsistent data in cases where there are no adequate concurrency control facilities provided. Finally, since the applications each work independently with their own ecosystem of data files, it is hard and expensive to integrate applications aimed at providing cross-company services. Although this file approach to data management has serious disadvantages, many firms still struggle with legacy file-based systems in their current information and communications technology environment. The emergence of database technology provided a new paradigm for data management. In this database approach, all data is stored and managed centrally by a DBMS as illustrated here. The applications now directly interface with the DBMS instead of with their own files. The DBMS delivers the desired data upon request to each application. The DBMS stores and manages two types of data: raw data and metadata. Metadata refers to the data definitions that are now stored in the catalog of the DBMS. This is a key difference with the file approach discussed earlier. The metadata is no longer included in the applications, but is now properly managed by the DBMS itself. From an efficiency, consistency, and maintenance perspective, the database approach is superior to the file approach. The database approach results in a loose coupling between applications and data. It also provides user-friendly and efficient facilities for data querying and retrieval. In the file approach, every application had to explicitly write its own query and access procedures. Consider the following example to the left in pseudocode. Basically, we first open a customer.txt file and read the first record. We then implement a while loop that iterates record by record through the file until the end of the file, as indicated by EOF customer, is reached. If the desired data is found, customer.name equals Bart, it will be displayed. Obviously, this requires a lot of coding. Because of the tight coupling between data and applications, many procedures would be repeated in various applications, which is again not very appealing from a maintenance perspective. DBMSs provide database languages that facilitate both data querying and access. A well-known language is Structured Query Language, SQL. As the term suggests, SQL can be used to formulate database queries in a structured and user-friendly way. It is one of the most popular data querying standards used in the industry. An example SQL query that gives the same output as our pseudocode to the left is shown to the right of my slide. Here, you only need to specify what information you want. In our case, we want all customer information for customer Bart. This SQL query will then be executed by the DBMS in a transparent way. In the database approach, we only need to specify what data we are interested in, and no longer how we should access and retrieve it. This substantially facilitates the development of database applications because we no longer need to bother with writing complex data retrieval procedures.